So acetazolamide is an carbonic anhydrase inhibitor. The heterocyclic ring which it possesses, this is the structure of acetazolamide. The heterocyclic ring is thiadiazole. So definitely we have to build two substitution, acetamide and second is sulfamoyl on thiadiazole ring. Okay. For that purpose, now concentrate. We are starting with hydrazine, NH2, NH2. Okay, it is a diamino compound, diamine. So it is hydrazine. It is reacted with ammonium thiocyanate. Now please concentrate. Ammonium thiocyanate is a salt. Now ammonium thiocyanate, the Lewis structure is like this. This is an ammonium ion which is having positive charge since nitrogen is attached from four sides. And this is thiocyanate. S, single bond C, triple bond N. Okay, and sulfur is having negative charge. Sulfur is having negative charge. So this is ammonium thiocyanate. The Lewis structure of ammonium thiocyanate is very important to understand so that what exactly is happening in this reaction of hydrazine and ammonium thiocyanate we can imagine. Now what is going to happen? What is going to happen? See the product. The product CSNH2 group is attached to both nitrogen, and both nitrogens have lost one hydrogen. Okay, so NH2 has become NH, C double bond S, NH2, C double bond S, NH2. So one molecule of hydrazine is reacting with actually two molecules of ammonium thiocyanate. So I have written here the thiocyanate anion. What will happen? The lone pair of electron on nitrogen is going to attack the carbon because it is triply bonded to nitrogen, 2 pi bonds. So it is electrophilic. Pi bond will shift on nitrogen. Okay, pi bond will shift on nitrogen. And then what will happen? It will acquire one hydrogen, proton, NH. So you imagine what is going to happen. Nitrogen getting attached, it will lose one hydrogen. This nitrogen will gain one hydrogen, and C double bond N H. You will get C double bond N H. Okay. Then what is going to happen further? The sulfur will shift its pair of electron towards carbon to form sulfur carbon double bond, and second pi bond will shift on nitrogen. Since second pi bond shifts on nitrogen, it will acquire one more hydrogen. It will become electron rich and it will acquire one more hydrogen. So NH will become NH2. Okay. So nitrogen will get attached to C carbon double bond S single bond. Now single bond will remain because 2 pi bond have shifted on nitrogen. Single bond NH2. So this is the same thing. Okay, this is same thing. What has happened? Nitrogen has attached to C double bond S single bond NH2. So triple bond, see triple bond, C triple bond N has got converted into C single bond NH2. Yes. So this is a thiourea type of compound. Okay, thiourea, where two thiourea residues are attached to one another. So what is going to happen now further? Now cyclization is going to take place. How cyclization is going to take place? So one of the sulfur that is C double bond S is going to act as a nucleophile. How? So just concentrate. The pair of electron on sulfur will attack this carbon. then what is going to happen? What is going to happen? Yes, the pi bond will shift on this sulfur and it will acquire one hydrogen and SH. And further, there will be removal of this NH2 in the form of ammonia. How? In acidic condition. This nitrogen, one of the nitrogen, there are two nitrogen like this, one of the nitrogen will get protonated and it will get out. It will break bond with the carbon and it will get out in the form of ammonia. Okay, so what you are going to get then? After all these electron transfer, electron relocation. So this sulfur will form a bond with carbon, pi bond will shift on sulfur. So cycle will get formed. Here cycle is going to get formed. And further aromatization is going to take place. These two nitrogens are going to lose hydrogen, so that two pi bonds are going to form. So their pair of electron will move here, here pair of electron is going to move here, and definitely that will cause this type of electron relocation. So one of the NH2 will get out ultimately in the form of ammonia and will get a double bond here, a cycle which is thiadiazole. What is this? Thiadiazole. Okay, now the cycle is ready. Cycle is ready. Now we want two types of substitution. First is acetamide. So this nitrogen will be simply acetylated in the presence of acetic anhydride. Acetic anhydride, you know that you might have used acetic anhydride for the synthesis of aspirin, where salicylic acid is acetylated in the presence of acetic anhydride. So that acetic anhydride, acetic acid mixture, acetylate means acetyl group get attached to the nitrogen. See, NHCOCH3. COCH3 is the acetyl group. Okay, this is acetylation. That's why this process is called as acetylation. So COCH3 get attached to nitrogen, NH2 become NH. Okay, so one of the substitution is ready, NHCOCH3. Now we want sulfamoyl group here, sulfamoyl, that is SO2 NH2. Keep in mind, it is not SH. So this sulfur needs to be oxidized. We want to add oxygen, so that is carried in presence of aqueous Cl2, chlorine. Okay, chlorine oxidation process is carried out. So sulfur get oxidized. Sulfur loses hydrogen, it acquires two oxygens, so SO2, and as you are carrying in presence of Cl2, one Cl will also get attached to the sulfur. So SO2 Cl group get formed there. Now it is very easy to substitute Cl because Cl is attached to sulfur. You know the group, how this group looks like. Sulfur, this is double bond oxygen, okay, and single bond Cl, and this is the attachment. So what is going to happen? This ammonia, then SO2Cl when get formed, the next step is treatment of this compound, intermediate. This is an intermediate. Okay, this is an intermediate. It will be reacted with ammonia. Ammonia will definitely attack electrophilic sulfur because it is attached to chlorine. Chlorine will live. So NH3 will become NH2, SO2 NH2 group we are going to get ultimately. Look here now, SO2 NH2. So this is the synthesis of acetazolamide. Okay,